Okay, good afternoon all. We will start our lecture. So today we will start with the next part of unit number 6, that is related with the pumps. Last lecture we saw something about turbine. Now today we will start with the pump. In first lecture we have defined hydraulic machines. In that hydraulic machines we define what is meant by pump and what is meant by turbine. So these are the mechanical devices. So hydraulic machines which convert the mechanical energy into hydraulic energy is called as a pump. Here we are converting mechanical energy into hydraulic energy. So here generally always hydraulic energy is in the form of pressure energy. If mechanical energy is converted into pressure energy by means of centrifugal force, the hydraulic machine is called as a centrifugal pump. That centrifugal pump we are supposed to study. So once again listen the definition. If the mechanical energy is converted into pressure energy by means of centrifugal force, conversion of energy from mechanical to pressure is done by centrifugal force. So it is called as a centrifugal pump. Centrifugal pump is exactly reverse of a inward flow radial reaction turbine. In case of centrifugal pumps, what happens? The concept behind it is it works on the principle of force of vortex flow, which means when certain mass of liquid is rotated by external torque, the rise in pressure means pressure head of the rotating liquid takes place. For that, generally, I always take one example. If suppose we are having one bucket and that bucket is full of water. If suppose we start rotating that bucket with high speed or with high velocity, or we call it as a with high RPM, the bucket is full of water. One end of that bucket is open, other end is closed, as we know, and we started the rotating that bucket. What will happen? Centrifugal force will act on the bucket, on the water inside the bucket, so that water will not come out of the bucket. If suppose there is a system in such a way that bucket end has small hole, it is rotating, and during that process if I have one small hole, then what will happen? Due to the centrifugal force acting on the top of the bucket will create a certain centrifugal force and water will leave from the hole which is at the bottom of a bucket. That simple principle is utilized while constructing such type of a centrifugal pumps. Then the rise of pressure head at any point in a rotating liquid is proportional to the square of tangential velocity of a liquid. So it is nothing but v square by 2g, that is velocity head. Thus the outlet of the impeller, if suppose the outlet of the impeller where radius is more, the rise of pressure head will be more and liquid will be discharged in the outlet. So let's see the construction. How is the working of a pump? So it has, as a diagram, in the diagram you can see, it has just a minute. Construction wise, if we go, First component is called as a impeller. So impeller is nothing but it is a rotating part which is mounted or which is connected to the external electric source. So this is impeller. The rotating part of a centrifugal pump is called as a impeller. It consists of series of backward and curved vanes. So this impeller, if we consider this as the impeller, then here eye of the impeller, and it has number of vanes, or which we call it as a blades. Curved vanes are there. The impeller is mounted on a shaft which is connected to the shaft of electric motor. It rotates with certain velocity, and water enters to that impeller from the center, or which is called as a eye of a pump. tell me up to what point I was there. ऊपर इन साइन है in between network problem was there, so I was out of the class. From which point I have to tell me fast. So I was telling about the pump, the different kinds of pump. So I will get selected to one. So the is Impeller, second was casing, and third was third component was section pipe, which has footwall, and fourth component is delivery pipe. These are the basic components. I provide the notes regarding the basic components of pump. I will start with the work done consideration of a centrifugal pump. For that, we will have velocity triangles. Remember, this will be considered related with the theoretical part will be considered this pump. Just remember these considerations. For this, let's consider a impeller which has one blade. Now let's draw the velocity triangle, and this velocity triangle is related with the center. This is from this center. So this is center of a impeller. From this coming to the one is perpendicular, another is horizontal. So this is V of 1 and this is U1. U1 is the velocity of blade at the inlet and F1 is the velocity of flow. And at the outlet, I just redraw the blade. I have to draw a blade which is in the connection of center. Like this, I have to draw the blade. Then outlet velocity triangle will look like this, where it is VF2. It is same the concept which we have seen in previously. It has two triangles VF2. This is also this is V2 and VW2, and total is U2. Here, what we are considering, this is vertical component is, this is VF2 and this is VR2. So, in case of centrifugal pump, what we should know is the work done, and that work done is given by simple formula. We don't require the derivation. Just remember 1 by G VW2 U2. Because what is happening, VW1 is here 0. As we know, work done will be here negative, and the work done formula which we know previously is the same which we have used in case of a turbine, that is 1 half BW1 U1 minus BW2 U2, and in that case, that is, I will write minus because it is exact opposite. It is 1 by G VW1 U1, but because here U1 is not equal to U2 as in case of Pelton wheel, VW1 U1 minus VW2 U2, which will result in VW2 U2 minus VW1 U1, and VW1 is 0, so it will give work done formula, which is 1 by G VW2 U2. So this is one formula which you have to remember. Then efficiencies are there. That is suction head means what? That is S suction head. Then delivery head, which is given by HS and HD. During the practical, we saw this. It is a vertical head or vertical height of the center line of the centrifugal pump above the water surface to the tank of a pump. Means if we see in case of the diagram, then from here to here, from the water level to the center, this is SH, and the vertical distance between the center line of the pump and the water surface in the tank where we are sending the water. If suppose here is the total maximum height, then it is HD. So we are measuring the distance from the center of a pump. Below this height, this is the lower level of water. This is highest level of water. In between, we are measuring the distance. And static head is there. Last term is called as a static head. Static head is nothing but HS, which is equal to HS plus HD, and it is in the capital. Small hs plus small hd will be given as SS. Then there is a concept of manometric head, which is defined as the head against which pump has to work, which is given by HM. Head against which pump has to work, which is nothing but VW2 U2. This is the work done it has to do minus losses. HM is nothing but head against which pump has to work. Then efficiencies, there are some efficiencies which we have seen in the previous. Same type of efficiencies are there, but here names are different. H man means manometric efficiency, which is given by manometric head divided by head imparted by impeller to water. Head imparted by impeller to the water means VW to U2 upon G. Means in other words, HM manometric head divided by VW to U2 upon G, that is work done. So it is nothing but GHM upon VW to U2. You just remember these definitions only from the point of these pumps. Then next comes the mechanical efficiency, which is nothing but power at impeller divided by, that is output, divided by power at shaft. Power at shaft, which is nothing but mechanical efficiency, and it is calculated by the formula W by G VW2 U2 upon 1000. And it will be divided by shaft power. That is power at impeller divided by shaft power. And overall efficiency can be calculated finally as a third. Overall efficiency is nothing but manometric efficiency multiplied by mechanical efficiency. So just remember these three definitions of pump related efficiencies, and remember the velocity triangle. Once again I will draw that velocity triangle. There will not be any problem based on this pump, that is definitely. So we are having such type of a pump blade. So if suppose the theoretical problem comes, theoretical things will come. So here V1 is here, and which is equal to VF1. This is VF1, this is U1, and here is the outlet velocity triangle, where VR2, VF2, U2, VW2, U2 is nothing but total. This is U2, this is VW2, this is V2. This is the blade, and this angle is called as beta, and this angle is called as a phi. The direction will be always away from the turbine, impeller blade, and here directions are like this. So just remember this velocity triangle as a reference point of view. In general, what you have to remember, you have to understand the construction and working of a centrifugal pump and various definitions as a point of syllabus. These definitions and all other things I will share today itself on Moodle. Start reading, start finishing the unit number 5 and unit number 6 as early as possible. If suppose in between some doubts are there, still we have 1 week with us. Come with the study, ask me the doubts, try to solve 1-2 problems based on the turbine. If suppose there are doubts, we can solve together in next week. We will take one more type of revision lecture on these 2 units once again in the next week, so that we will have more practice of the problems, as we have gone little bit fast. Now tell me, let me know any doubt. So in the exam, you have to draw this diagram. If question is there, explain the construction and working of a centrifugal pump. You have to draw this diagram and explain each and every component of pump. And this such type of a theoretical question will come for 8 marks. So for 8 marks, diagram will carry some marks, plus each of the component, that is impeller, types of impeller, impeller, casing, types of casing, suction pipe, delivery pipe, everything has to be explained neatly. Similarly, in case of turbines, the construction and working of a Francis turbine and construction and working of a Pelton wheel, the efficiencies of Pelton wheel, efficiencies of turbine, efficiencies of centrifugal pump, all these are the theoretical questions. So there is scope for writing whatever things you know in detail for these questions. And these questions are limited only. And out of that, 4 questions will come, as I am saying once and again. In unit number 6, these many theoretical questions are there, and one derivation is there for Pelton wheel. Limited type of questions are there, so it will be easy for you to achieve those 24 marks. Once again, I am telling objective questions you have to, those are compulsory. On each unit there will be 2 questions, and you have to means as you know, we have done so many objective type questions during our on modal activities. Same way the questions will be asked, but these will be strictly multiple choice questions only. 4 options will be there out of 1, which you have to write correctly in the answer sheet. So based on this unit number 6, again objective type questions will be also less, because the scope is less. The objective type questions will be related with the turbines, which are generally based on the difference between reaction turbine and different what is mean by impulse turbine, the working principle of impulse turbine, working principle of reaction turbine. Based on that, objective type questions will be there. So concept is simple. The concept of impulse turbine we have seen. As we know the working of centrifugal pump now, centrifugal pump exactly works opposite to the reaction turbine. In the reaction turbine, water is coming from outside to inside. In case of pump, water is means outside to inside, water is coming. But in case of pump, it is coming from inside to outside also. Like that is possible. So today we will end up this session little bit early. I have one meeting. So is there any doubt? If there is no any doubt, enter your roll numbers in the chat box, and we will officially we are finishing the syllabus, but in the next week we will have more sessions. Remember, in the next week, we will have small Viva oral, okay, which will be based on unit number 5 and 6, which will be one of the part of our FET component. We will conduct small Viva online mode only, which will be based on unit number 5 and unit number 6. So I request everyone to start studying the unit number 5 and unit number 6. All videos except last 2 lectures are already posted on WhatsApp group, as well as you already have Bansal book with you. I will provide the notes till today evening, means the part from the book which is important for you, and read those things. We will have small Viva oral online mode on last 2 units only. Is it okay?
सर पीओई कोणत्या कोणत्या सब्जेक्ट या केपेला?
फक्त आपल्या सब्जेक्टला आहे. फक्त फ्लुइडची जी लॅब आहे आपली, फ्लुइड अँड थर्मो, त्या लॅबला पीओई आहे.
म्हणजे कॅड वगैरेची प्रॅक्टिकल एक्झामिनेशन नसते का?
नाही आहे. सिलेबस तुम्ही चेक करत नाही रे, म्हणून असं प्रॉब्लेम होतो. सिलेबस मध्ये स्पष्ट लिहिलेलं आहे. सिलेबसची कॉपी मुडलवर माझ्या तर आहे, एकदा चेक करा सगळं.
ओके सर.
आणि तुमची पीओई एक्झाम झाल्यानंतर आहे, त्यामुळे त्याच्यात टेन्शन घेऊ नका. फक्त जर्नल रेडी ठेवा. जो पार्ट तुमच्याकडे आहे तो सगळा रेडी ठेवा. जो नाही आहे तो मी देतो 2 दिवसात. त्याच्यात फक्त तुम्ही व्हॅल्यू ऍड, प्रिंट मारा, व्हॅल्यू ऍड करून तयार ठेवा फाईल. ओके. Hope everybody has entered the number in the chat box. Only 20 students are present today.